In this online lecture, we are going to look at chemistry and the topic that we are going to be considering here will be redox reaction. Redox reaction. Many people from the previous videos that I made requested for redox. Well, it's a very simple complex, only if we have the fundamental knowledge of this. Look at this. The word redox comes from combination of two words. The first one is reduction, while the other one is coming from this word ox, which stands for oxidation. The word reduction, if you pay attention to this, you will notice that it looks like an English word that means to reduce or to decrease. Then the word oxidation comes from the word this element, the word oxygen. So clearly you can see that the word oxidation means oxygen, while the word reduction means to reduce or to decrease something. You can see that both of them, they are reactions. And generally, whenever we talk about reaction, anyhow you are doing your reaction, maybe you are preparing food or you are preparing whatever, reaction always involve you adding things together or you subtracting things from one another. Because according to John Dalton, in his atomic theory, he told us that for every chemical reaction, there must be combination, which stands for addition, or there must be separation, which means subtraction. But here, what we are going to be using here now to call this reaction is either we are adding something or we are subtracting something. So when I add or I remove, I have done reaction either way. So when we look at this word oxidation reaction, since the word comes from the word oxygen, it's any reaction that involves addition of oxygen. This is what we call oxidation. So oxidation can therefore be defined now as the addition of oxygen. That's simple. From the word oxidation, oxygen. From the word oxygen, oxidation. So whenever you hear the word oxidation, it simply means addition of oxygen. This is the definition of oxidation in terms of oxygen. Then, if I now talk about reduction, it simply means the opposite of oxidation. So it means reduction can now therefore be defined as the removal of oxygen. So if it's not oxidation, then it is reduction. So if I add oxygen from the word oxidation, but if I remove oxygen, then it is called what? Reduction. Now that we are very okay, we can now define oxidation reaction and reduction reaction. Oxidation reaction can be defined as the addition of this element oxygen, while reduction can be defined as the removal of the element oxygen. We want to quickly look at another way that we can define a redox reaction in a case whereby we don't have oxygen. Then the scientists think that, okay, one thing that we are very used to in our various homes is what we call water. In this water, you can see this word here. We have oxygen, and the other element that we have there is hydrogen. So then you can think about you have already defined redox reaction in terms of this one. Then you should define it in terms of the other guy, that they are both present in water. And who is the guy? Hydrogen. Whatever oxygen is doing, hydrogen will do the opposite. Like the two of them, they are opposite to each other. So therefore, if I have defined number one, oxidation in terms of what? Oxygen. Then I should also be able to define it in terms of what? Hydrogen. Whatever oxygen is doing, hydrogen should do the opposite. That's okay, right? So that means that if I want to define oxidation in terms of oxygen, what do I say? Addition of oxygen. So that means if I want to define oxidation in terms of hydrogen, I'm going to say the opposite of oxygen. And that will be what? Removal of hydrogen. So in terms of hydrogen, oxidation can be defined as the removal of hydrogen. But then, whatever definition we give to oxidation, the opposite of that definition goes for who? Reduction. So therefore, I can now say oxidation can be defined in terms of oxygen as addition of oxygen, in terms of what about reduction? Oxidation can be defined as the removal of oxygen. But if I want to talk about hydrogen, like the definition of these guys in terms of hydrogen, oxidation simply means removal of hydrogen, while reduction means addition of hydrogen. So you can see oxygen and hydrogen, they are opposite to each other. Oxidation and reduction, they are also opposite to each other. Then, if these two guys are valid, we now decide to see what about a reaction that does not contain oxygen and hydrogen. How do we now divide them? All our elements in the periodic table, they are divided into 3. And these 3 ways we divide them is based on the number of electrons that we have in the outermost shell. We have some elements that have 1 electron in the outermost shell. We say they belong to group 1. The people that have 2, they belong to group 2. Group 3, group 4, group 5, group 6, group 7, and group 8 or group 0. If you look at the elements that belong to group 1, hydrogen have atomic number 1. So hydrogen belongs to this place. So that means that hydrogen have 1 electron and 1 proton. But if you look at the element oxygen, it has hydrogen, helium, lithium. If you can't, it has atomic number 8. And that will give you what? 2,6. If you are trying to do this shell notation. Somebody that have 1 in the outermost shell, but they should have, every element are meant to have 8. So if somebody is having 1, that means that it remains how many to make 8? 7. Nobody will give you 7, so you throw your 1 away. What about when you have 2? You need somebody to come and give you 6, right? But it's not possible. So you rather give somebody having 6 your own 2. What about if you have 3? You will lose your 3 to somebody having 5. But what about when you have 4? That means we are going to London and both of us have $4,000. We will laugh. So therefore, people that have 4, they always share. They don't lose and they don't gain. So they do covalent bonding. But the people that have 1, 2, and 3, what do you think they will always do? They will lose what? Electron. But if you look at somebody from group 5, group 6, and group 7, this guy remain just 3 to make 8. Remain 2 to make 8 and remain 1. These people, they are going to gain what? They are going to gain electron. So if you look at all these people that we have here, this one will lose electrons, this one will gain electrons. Remember that in every neutral atom, the number of protons must be equal to the number of electrons. But the charge on electron is always negative. So therefore, when these people lose electron, their electron is now less than their proton. So therefore, they will now become positively charged. Any element in group 1, group 2, and group 3, they will always lose electron and have more positive. So they now become positively charged. We now decide to call them a common name. And that name is what? Electropositive elements. But the people from here, they always gain electron. Since number of electrons is also equal to proton for them, when they gain more electrons, what happens? They have more electrons than positive. So that means they will have more negative charge than positive. So they always become electronegative, because they gain electron which is negatively charged. But the people in group 4, they don't gain, they don't lose. So we call them metalloid. So people that are here, they are metals. While people that are here, they are called non-metals. If you look at the reason why I have to explain these two groups, is because the element hydrogen belongs to this group. Hydrogen loses electron to become hydrogen plus. Oxygen is belonging to group 6. Atomic number 8, 2,6. It always gains 2 electrons and become O2 minus. If you look at what I have here, oxygen is a member of electronegative elements. Hydrogen is a member of electropositive elements. Whatever I say about hydrogen, I can say it about generally for the electropositive elements. Whatever I say for oxygen, I can say it generally for all the members of the electronegative elements. Therefore, we have been able to define oxidation and reduction in terms of oxygen. We have been able to define oxidation and reduction in terms of hydrogen. We should be able to define it in terms of electropositive elements, and we should also be able to in terms of electronegative element. One term for definition. So that means that if I have defined in terms of oxygen, hydrogen, I should be able to also define in terms of electropositive and electronegative elements. So that means that the same definition that you have given to oxygen is what you will give to all electronegative elements. The same definition you have given to hydrogen is what you give to all electropositive elements. So let's go once again. Oxygen can be defined as the addition of oxygen. Reduction can be defined as the removal of oxygen in terms of oxygen, right? What about hydrogen? Oxidation can be defined as the removal of hydrogen, opposite of oxygen. Reduction can be defined as the addition of hydrogen, opposite of oxygen. Then, what about if I want to use electronegative elements? They are also the same as oxygen. So I can define oxidation as the addition of electronegative elements. Or I can now say reduction can now be defined as the what? Removal of electronegative elements. I can now define redox in terms of electropositive element now. I will now say oxidation can be defined as the, this one is opposite of electronegative. Electronegative is a member of oxygen, so it will be opposite of these people. So therefore, oxidation can be defined as the removal of electropositive elements, while reduction can be defined as the addition of electropositive elements. In these definitions, we have been adding these things and we have been removing. What exactly are they doing whenever we add them? Imagine you adding a girl to your schedule. Automatically, your money will be reduced. But imagine if a boy is coming, waiting on signals, he will pay for himself, then you pay for yourself. So that means that whenever we add a girl to a game, automatically some money must be gone. But whenever we remove them, then excess additional money should come. So due to that, we now want to look at, if I add oxygen to a place, addition of oxygen, I call it oxidation, right? If I add oxygen, I call it oxidation. Why? Why is that happening? The reason is that oxygen is having atomic number 8, and it will ionize, it will be 2,8. It will be 2,6, meaning it will gain 2 electrons. So the reason why we actually say that oxygen, addition of oxygen will cause oxidation is because oxygen used to gain electron. Oxygen used to gain electron. Why do we say addition of hydrogen is reduction? The reason is that hydrogen used to lose electron. Now, it means that our oxidation and reduction is basically because of gain and loss of electron. Imagine, if I add electron to your life, it means I have added negative to your life. If I remove electron from your life, it means I have been able to successfully remove negativity from your life. Now, which one would you prefer? Which one would you like to say your life is reducing? This is when I add electron to your life. But if I remove electron away from your life, then it's like I'm removing bad thing because electron is negative. So you removing electron from somebody, it means the person will go up. If you add electron to somebody, it shows that the person will go down. So therefore, what will oxygen do anywhere oxygen gets to? Oxygen will help you to remove electron from the place. So that means that these people here, whenever we add oxygen, oxidation occurs. Why? Because oxygen will remove electron. Whenever we add hydrogen, what will happen there? Hydrogen will donate electron there. So then, that means we have been able to add negative. If you add negative to something, that thing is what? Reduced. But what about if you remove electron from somewhere? What happens? That place is going up or oxidized. If I assume that the opposite of reduce is oxidation or like increase. So therefore, we now want to give the 5th definition of redox reaction as in terms of the movement of this thing called electron. So that is in terms of what? Electron transfer. So in terms of electron transfer, I can now say that is electron a good thing or a bad thing? I'm saying bad thing because electron is negatively charged. So if I add electron to somebody, that means I've added negative to that person. So the person should be what? Reduced. Therefore, I will now define reduction as the addition of electron. I will now define oxidation as the removal of electron. Because if I remove electron from you, you will go up. If I add electron to you, you go down. And this is what will now take me to the sixth definition, which is what happens when I add electron to you. If I add electron to you, then your sign on your head, for instance, look at chlorine with atomic number 17, is 2,8, 7. Will it gain electron or lose electron? Having 7 in the outermost shell, we all know that it will gain 1 electron, right? So the 1 electron this guy gained makes the guy have more electron than plus, because it was having 17 proton, 17 positive, and 17 electron negative. Now it has gained 1 electron. So the number of electrons here is now 18 electrons. While the positive here is still 17 positive or proton. Who is small? 17 cancels 17. I am having 1 Sx electron. Therefore, chlorine ion is Cl minus, meaning it has gained 1 electron. So in this case now, you can see, because I added electron, the number on the head here was 0 before. Now it is negative 1. Is that an increase or a decrease? So this reaction here shows that I have added electron, and this is what we call a reduction. So that means I can now divide my sixth definition in terms of this thing on the head here, and the name of this thing here is called oxidation number. So I can divide it in terms of oxidation number. So how will I define that? If the oxidation number goes down, like this case, from 0 to minus, it's reduced. So that is reduction. But then, let's look at another case. Let's look at sodium. Then, sodium can turn to Na+. How? Atomic number of sodium is 11. 2,8, 1. What will happen to this one? Will it gain or lose? Or what? It will lose 1. When it loses 1 electron, then the proton is still 11 and the electron remains 10. So proton is more than 11. That's why the guy gained +1. Do we add electron or remove electron? Let's do like this. We have removed 1 electron. But in chemistry, this minus sign is not allowed. So do it as if you are doing math. Transfer this electron to this side. So it will become plus electron here. So rub this one away. Just like in math, when I have 2 plus x equals to 3. If I transfer this plus x here, it's going to become minus x. That's all I've done. So what can you say about this chlorine that we did example on the other time? The chlorine was neutral. What does it do? It gained 1 electron. So I'll just write plus electron. Yes, it's allowed to write plus, but it's not allowed to write minus. But if I carry this guy here, so that's why you ask questions sometimes. Some people ask, why? How do I know that I'm to write plus electron here, or I'm to write it on the other side of the equation? You will write it here if you are adding electron. But the reason why we don't write it here when we are subtracting is that if I subtract electron, I would have written minus electron here. But minus is not allowed. So I have to carry it to the other side and write it there as plus. So that is why I don't write minus electron here. This shows that I remove electron. But if you are still confused, bring this guy here. It becomes minus electron, showing that you have removed electron from the sodium. While here, it shows that we have added electron to the chlorine. So in terms of oxidation number, what is the oxidation state that we have here? 0, right? And what do we have in this case? Plus. So moving from here to here, it is oxidation. Why? Oxidation can be defined as the increase in oxidation number. Reduction can be defined as a decrease in oxidation number. Go. Okay, so the number, the oxidation number that we have here. So you can see now that this guy is 0 and is +1 here. That's an increase in oxidation number. While here, there is a decrease in oxidation number from 0 to this. So, and you can simply see that example here. For instance, look at our ion. If I have ion 3 plus here, and then this guy go and gain 1 electron, can you see I've added electron? Do you think it will be oxidized or reduced? Addition of electron will reduce it. So the guy will become Fe then we are going to have 2 plus on the end here. So in this case, you can see clearly that this guy is reduction. How do I know? Plus 3 here turning to plus 2 here. And if I calculate the charge, plus 3 here and minus, this guy is having plus 3 minus 1 equals to, what do I have here? Plus 2. So if you do plus 3 minus 1, it's still plus 2 equals to plus 2. So charge is balanced, showing that we are right. Is this now oxidation or reduction? Is reduction. Addition of electron in terms of electron transfer. Addition of electron is reduction. In terms of oxidation number, decrease in oxidation number is reduction. So in the next video, I'm going to do balancing of redox reaction. At the same time, we are going to look at a lot of examples on this thing. How UTME ask their questions, and how post-jam set questions, including WAEC, NEPO, and A levels like JAM, like IDMB, JUPEB, and other advanced